Okay, tonight we're going to learn about the converse of the Pythagorean theorem. So before we do, just a little bit more history on the Pythagorean theorem. In ancient Egypt, there was the Nile River and overflowed annually, flooding the surrounding lands. Well, this caused a problem because the Egyptians marked property, and the flood usually erased those markers. So they had to remeasure the land after the flood. Well, because most of the plots were rectangular, the Egyptians were smart and created a way to make sure they had right angles. And they did this by creating a rope with 12 equally spaced knots, which could be used to create a right triangle, because we know if we have a right triangle, we have a right angle. Well, those 12 equally spaced knots ended up making two legs and a hypotenuse that satisfied the Pythagorean theorem. And it was this 12 equally spaced knot rope that Pythagoras used and other ideas from the ancient Egyptians to help create his theorem, the Pythagorean theorem. What I need you to do is I need you to pause and fill out the second column of this table like the example. Here are the answers. So here are some guide questions. Using the table you just filled out, make a conjecture, which is an educated guess about what kinds of triangles satisfy the relationship a squared plus b squared equals c squared. And also using the table, make a conjecture about what kinds of triangles that do not satisfy the relationship a squared plus b squared equals c squared. So you're looking for triangles that do satisfy the relationship and triangles that do not satisfy the relationship. Now, triangles that satisfy the relationship a squared plus b squared equals c squared are right triangles, and we kind of know that because of the Pythagorean theorem. We also know that non-right triangles are triangles that do not satisfy the relationship a squared plus b squared equals c squared. And what are we actually leading to? We're leading to the converse of the Pythagorean theorem and Pythagorean triplets. A converse of a theorem is the opposite idea of that theorem. So the converse of the Pythagorean theorem states that if three side lengths satisfy the relationship a squared plus b squared equals c squared, they create a right triangle. And we use this converse to create to find whole numbers that create right triangles, and we call these whole numbers Pythagorean triplets. 3, 4, and 5, and 5, 12, and 13 are examples of Pythagorean triplets. Now, if we multiply a set of Pythagorean triplets by the same number, we will still have Pythagorean triplets. So 6, 8, and 10, 15, 20, 25 are all Pythagorean triplets. There are an infinite amount of Pythagorean triplets. So here's some on your own practice. So we want to know if the numbers 25, 60, and 65 are Pythagorean triplets and explain why. And do the side lengths 30, 40, 50 make a right triangle and explain why. And you want to make an equation that would represent the set of Pythagorean triplets being multiplied by 2 using a squared plus b squared equals c squared. You will get these answers tomorrow in class.